Your prime numbers are numbers that can't be evenly divided by any other number besides 1. So 9, for example, you could divide that by 3 or break 9 down to 3 times 3. 11, on the other hand, can't be divided by any other integer evenly, so the most you could break 11 down to is 11 times 1. So 11 is prime, but 9, because we broke it down to 3 times 3, is not prime. You should have a simple list of prime numbers memorized. Most people remember that 3, 5, 7, 11, and 13 are your primes, and you can keep building the list from there. 2 is also considered a prime number, but 0 and 1 are not prime numbers. You should have your prime numbers memorized up to about 50. Beyond 50, however, it's much more realistic to be able to identify when numbers are not prime. For example, we know 2 is a prime number, but any number that ends in an even digit, like 14, we know is divisible by 2, which means it's not prime. So in this case, 14 breaks down to 2 times 7. While I may not know exactly what will divide into 1022 evenly, I can see that the number ends in an even digit, so I at least know that I could divide it by 2. So I know the original number is not prime. In this case, it breaks down to 2 times 511. We have a similar situation with the number 5. 5 is prime, but anything that ends in 5, or 0 for that matter, can be divided by 5. So 15 breaks down to 3 times 5, and 10 breaks down to 2 times 5. While I may not know exactly how to divide 4085, I can see that it ends in a 5, so it's divisible by 5, which simply means that it's not prime. There's also a pretty cool trick known as the rule of 3. And that is, when a number is divisible by 3, the individual digits of that number will add up to a multiple of 3. For example, we can see that 12 divides into 3 times 4. And if I were to take the numbers 1 and 2 and add them, so 1 plus 2, I get the number 3. With 18, I know that 18 is divisible by 3. 18 breaks down to 3 times 6. But if I didn't know that, I could take the digits 1 and 8 and add them together, and I would get 9. And 9 is a multiple of 3. So when I have a very large number, like 24,381, to see if it's divisible by 3, I can simply add all the digits together. In this case, I get 2 plus 4 plus 3 plus 8 plus 1, and that equals 18. And then 1 plus 8 equals 9. And 9 is a multiple of 3. So even though I haven't actually done the division, I know that 24,381 is divisible by 3, therefore I know it's not prime. In this problem, we're being asked to add all of the prime numbers between 80 and 90. So our potential candidates are 81, 82, all the way down to 89. Right away, we can eliminate all of our even numbers because we know they're divisible by 2. And we can get rid of 85 because we know that is divisible by 5. The last tool I have is the rule of 3. I can take 81 and I can add 8 plus 1, and that equals 9, which is a multiple of 3, so I know 81 is not prime. For 83, 8 plus 3 adds to 11, so 83 is a possible prime. In 87, 8 plus 7, that's equal to 15, which is a multiple of 3, so 87 is not prime. And lastly, I have 89. If I add those digits together, I get 8 plus 9, which is 17, and that's not a multiple of 3. So without memorizing all of the prime numbers, I was able to identify that 83 and 89 are my two prime numbers in my list simply by knowing how to eliminate numbers that are not prime.